Assalamualaikum warahmatullahi wabarakatuh. Today our group, which is group 1, want to discuss about the comparative study between the standard and code for ASME BPV section 8 division 1 and EN 13445. Our lecturer's name is TS Dr. Norizal bin Mustafa. Okay, for this study, it is intended to provide a broad viewpoint on the major different and factor to consider when choosing the most appropriate vessel design and code use. This section will evaluate the difference between these two type of code and standard, which is include a comparison of material properties and the others. Our group consists of 4 members, which is me, Muhammad Khairul Haziq. Second is Tirtishwaran. Third is Nur Shahidah Safia. And fourth is Izzat Izzuddin. For the introduction, what is the meaning of ASME BPV section 8 and also EN 13445? Okay, first, ASME code section 8 stand for American Society of Mechanical Engineers, ASME boiler and pressure vessel code section 8. There are around 12 code for ASME, and section 8 covered for unfired pressure vessel. 9,000, 90,000, and 25. Okay, for the EN 13445 is stand for the European Pressure Vessel Code. The difference is the ASME is for American Society Industry and EN for European Industry. The code and standard is all can be used. Next, what is the importance of code and standard? First is to set the specified rule and guideline to ensure the manufacturing of pressure vessel meet the industry standard, whether in European and also in the United States industry. Second is to ensure that during production of pressure vessel in industry, high level of caution and safety is followed. Then enlist the essential rules, regulation and guidelines that provide a direction to all the pressure vessel fabricator. Next is must comply, not only provide but must comply that it can help in avoiding accident because of an unidentified fault. Last but not least, make sure that their pressure vessel meet the recommended standard and are safe for use in all type of setting.
Hi, my name is Nur Shahidah binti Muhammad Aziz. My metric number is AN180001. Okay, I present of the code standard, which is in pressure vessel. Also have a code standard. Code standard is present for the law or the rules for pressure vessel. The code standard for the pressure vessel consists of design, fabrication, inspection, also the testing for the pressure vessel after we build. Some countries produce their pressure vessel by their own. When they produce their pressure vessel, they must have a standard code for to present their pressure vessel, which is for the example, India have their own pressure vessel, so they have a standard code which is IS 2825 for present their pressure vessel. To build the pressure vessel, we need to consider some characteristics, which is design of pressure vessel, temperature, scope, also the material for pressure vessel. For build the pressure vessel, for the standard we use is referred to ASME, because in ASME it provide the characteristic to build the pressure, which is fabrication, design, corrosion fatigue, and deformation for the materials before we make the pressure vessel. We need to refer the ASME actually, because in ASME is really important to we consider before we make it. Other than that, we also can refer from the EN 13445 because in EN 13445 also show us how to fabrication the pressure vessel, the design, the testing of pressure vessel, and so on. Also for the additional EN 13445, it show the requirement of the pressure vessel of nickel and nickel alloy. Also the pressure vessel equipment for pressure vessel made from aluminium and aluminium alloy. So it shows us the EN 13445 is more specific, but we can refer both of them, ASME and EN 13445, to be specific to make a pressure vessel.
Good afternoon to everyone. My name is Yadisharan. I'm from 4BNL. My metric number is AN180296. Now I'm here to talk about pros and cons of ASME BPV section 8 division 1. So the pros are permits joint efficiency of 1.0, 0.85 and 0.7. Secondly, a good economic advantage especially for the complex and costly vessels. Thirdly, it seems to be the current and future preference. Okay. Cons of ASME BPV section 8 division 1. Lowest allowable stresses for ferritic steel. Secondly, lowest tensile strength at ambient temperature for ferritic steels. Second slide. So pros and cons of EN 13445 code. Okay, there's a lot of pros and there's no any cons for this code. So firstly, highest allowable stress for ferritic steels. Secondly, highest tensile strength at ambient temperature for ferritic steels. Thirdly, provide the designer the opportunity to design. Lastly, construct thinner and less expensive vessels in very specific cases. Let's go to the next slide. Code parameter comparison. Material properties. Carbon and low alloy ferritic steels. An evaluation of the allowable stress based used by ASME and EN codes reveals some similarities as well as some significant differences. Okay, each of the code utilizes a 1.5 design margin on material yield strength. However, the design margin on ultimate tensile strength become progressively smaller for each of the codes. The difference in generally the key factor in explaining why the highest allowable stress are found in the EN code and the lowest are found in the ASME section 8 division 1. So the table shows the allowable stress for different design code. So for your information, FUT is ultimate tensile strength at design temperature. Fy 0.2T is equal to 0.2% offset yield strength at design temperature. And lastly, Fu 68, that means ultimate tensile strength at 68 degree Fahrenheit, which is 28 degrees Celsius. Parameter comparison. Austenitic stainless steel, a significant factor that contributes to the higher allowable stresses in the EN code is the comparison between the yields and tensile that is used for establishing the allowable. Table 2 shows that the EN 13445 allowable stresses are a function of the greater of two values, whereas in the ASME code, the allowable is always based on the lesser of two values. The EN 13445 allowable stresses for austenitic materials will typically be higher than those specified by ASME. The exception to this general observation would be for applications where slightly higher deformations are not detrimental to the equipment design. So the table shows the allowable stress and the various design code.
Assalamualaikum warahmatullahi wabarakatuh. I'm Izzat, and now I want to present about the conclusion. Okay, for the first, vessel that does not meet the code and standards is not legal for use. And second, code and standards must be followed in order to protect the workers from any kind of dangerous situation, in bracket catastrophic accidents. Third,
EN 13445 thus provide the designer the opportunity to design and construct thickness and less expensive vessels in very specific case. Next, the ASME could have a number of advantageous features which make them highly competitive. Okay, for the last, majority of pressure vessel expense in plant construction is concentrated in a small number of high pressure thick wall vessels. That's all from our group. Thank you.